The next leap in particle physics. Why a muon collider could unlock reality's secrets for decades. The quest to understand the universe at its most fundamental level has been dominated by massive, high-energy colliders. But the Large Hadron Collider, LHC, at CERN, despite its groundbreaking discovery of the Higgs boson, has hit a wall. Now, a radical new idea is gaining traction. Building a collider not with protons or electrons, but with muons' unstable, heavier cousins of electrons. This isn't science fiction. Technological advances are making a muon collider increasingly feasible, prompting serious interest from funding organizations and physicists alike. The limits of existing colliders, the LHC, confirmed the existence of the Higgs boson in 2012, a particle crucial for explaining why fundamental particles have mass. However, this discovery raised more questions than it answered. The Higgs boson's mass is unexpectedly small, defying theoretical predictions. Why is it so delicately balanced? The answer may lie beyond the reach of current colliders, which either lack the necessary energy or produce messy collision data that obscures subtle signals. Proton colliders, like the proposed future circular collider, aim to brute force their way to higher energies by increasing the size and power of the machine. But protons aren't fundamental particles. They are made of quarks and gluons, resulting in chaotic collisions. Electron-positron colliders offer cleaner interactions, but lose energy rapidly, limiting their potential. Why muons? A new approach. Muons, unlike protons or electrons, offer a unique advantage. They are fundamental particles, meaning their collisions are cleaner. Crucially, they radiate far less energy when bent around a circular track, allowing for higher energies without requiring an enormous tunnel. For years, the idea was considered fanciful. Muons live for mere microseconds before decaying. How could you build a collider with particles that vanish almost instantly? Technological breakthroughs are changing that. Advances in ionization cooling, a technique for compressing chaotic muon beams into tightly focused streams, are making the concept viable. The challenges and breakthroughs. The biggest hurdle is capturing and accelerating muons before they decay. Scientists produce muons by smashing protons into a target, creating a spray of particles. Turning this chaos into a coherent beam is a monumental task. The key lies in speed. The faster the muons move, approaching the speed of light, the longer they appear to live from an observer's perspective. Recent experiments, like the Muon G2 experiment at Fermilab, have provided hard-won expertise in handling muons at scale. Combined with theoretical studies pushing energy levels to 30 TeV, 4 times higher than the LHC, the muon collider is no longer a pipe dream. What could we discover? If built, a muon collider could unlock some of physics' deepest mysteries. The Higgs boson's true nature. Is it a fundamental particle, or is it composite built from smaller constituents? Matter-antimatter asymmetry. Why is there so much more matter than antimatter in the universe? Vacuum decay. Could our universe be in a precarious state, poised to collapse into a different reality? The Higgs field, which gives particles mass, may not be stable. A quantum fluctuation could trigger vacuum decay, fundamentally altering the laws of physics. A muon collider could test these scenarios with unprecedented precision. The future of particle physics, the muon collider, is now one of the leading contenders for the next major physics machine. Funding decisions will determine whether this ambitious project becomes reality. Building it would be a decades-long endeavor, but the potential rewards are enormous. We've been doing things the same way for many decades, says Sergo Jindariani, head of the US Muon Collider collaboration. At some point, we need a new approach, and colliding muons may be that. The Muon Collider represents a bold step forward. If realized, it could rewrite our understanding of the universe and reveal secrets hidden deep within the fabric of reality.